So, how do you give a power plant a grade? You don't grade it on a curve, that's for sure. You grade it against the perfect score, the one set by the laws of physics themselves. Today, let's put geothermal energy to the test and see just how close it can get.
You know, the ground right under your feet, it's like a giant natural battery, just humming with heat. So here's the big question. Why can't we just grab all that heat and turn it into electricity? A perfect 100% conversion. Well, it turns out there's a rule, a fundamental law of physics that applies to every single engine ever made.
And to get why, you've got to shift how you think about a geothermal plant. It's not just a big building with pipes. It's actually a special kind of engine, one that literally runs on the Earth's own internal heat.
So, deep down, any power plant that runs on heat, I'm talking geothermal, coal, even nuclear, is basically a heat engine. Its only job? Take heat, turn it into motion, and boom, you get electricity. Simple, right? Well, there's a catch.
See, a heat engine can't just use heat. That's not enough. It needs a temperature difference. Okay, think about an old school water wheel, right? That wheel isn't going to turn if all the water is flat. You need water up high and a place for it to fall down low. It's that drop that creates the energy. A heat engine is the exact same idea. Your high point is the hot source, and your low point is a cold place where you can dump the leftover heat.
So, let's look at a geothermal plant. Here's what's happening. They drill way down to pull up super hot water or steam. That's our hot side. They use that heat to spin a turbine, right? But then they've got this cooler water left over and they have to do something with it. That becomes the cold side, and it's that gap between the hot and the cold that makes the whole thing go.
Okay, so if that temperature difference is everything, that means there's a hard limit, right? A ceiling on how much work you can possibly squeeze out of the system. And yep, there is. There's a perfect, unbeatable efficiency score that every engineer on the planet is trying to get closer to.
And that perfect score? It's got a name. It's called Carnot efficiency. Think of it as the absolute theoretical maximum that any heat engine can ever reach. It's not really a goal you can hit. It's more like the cosmic speed limit. It's just a rule of the universe.
Now, this formula might look a little scary, but honestly, the idea behind it is super simple. It's just saying that the best you can possibly do, it only depends on two things, the temperature of your hot source and the temperature of your cold source. That's literally it. The wider that gap is between hot and cold, the higher your perfect score gets.
All right, let's actually calculate it. Let's take a pretty standard high-temp geothermal plant. We've got super hot steam coming up at 540 degrees Celsius, and we've got cooling water sitting at about 20 degrees Celsius. So first step, we got to convert those numbers to Kelvin. That's the absolute temperature scale that science runs on. Once we have that, we just plug them into the formula.
And what do we get? 64%. That's the number. For this plant, 64% is the perfect score. Now, in the real world, you're never actually going to hit that. There's always some energy lost. But that number, that's the ceiling. That's the 100 on the exam that all the engineers are studying for.
So you might be thinking, okay, if we can never actually hit 64%, who cares? Why does it matter so much to get as close as we can? Well, it all comes down to the real world, to things like money and resources.
I mean, why would a company spend billions of dollars on engineering just to bump their efficiency from, say, 35% up to 40%? What is the big deal about those few extra percentage points?
It's all about one thing, return on investment, ROI. You got to remember, building a power plant costs a ton of money, billions. So being more efficient means you are squeezing every last drop of electricity and revenue out of every single dollar you put in.
Here's another way to think about it. A more efficient plant gets you more power from the exact same geothermal well. You're not drilling more, you're not using more water, you're just being smarter with what you've already got. You're getting more bang for your buck.
So what's the bottom line here? Getting closer to that perfect score means we get more clean power out of one plant. Plain and simple. And that, in turn, makes geothermal projects way more profitable. And when they're profitable, you see a lot more investment in this incredible 24/7 renewable energy.
If there's just one thing you remember from all this, let it be this. It's our human ingenuity, our engineering, that unlocks the true value of the Earth's natural gifts. The closer we can get to that absolute physical limit, the more valuable and powerful that heat right under our feet really becomes.
Like what you learned? Make sure you subscribe to Energy Simply Explained for more. And hey, the next time you flip a light switch, just remember that invisible speed limit and the engineers who are racing to get just a little bit closer.